my name is Dana Golden. Today we're going to finish up our first video in the electricity section of the electricity markets lecture with a look at regulated and deregulated electricity markets. So this is kind of a misnomer. Deregulated electricity markets are also very regulated. FERC is still doing its job everywhere, and it's not like you can just charge whatever you want in these deregulated electricity markets. Actually, every electricity market is very regulated. Really, these markets are vertically integrated, and the utilities own the generators and the transmission and distribution. And in these markets, utilities own some of the generators and also all the transmission and distribution. So there is what's called a wholesale market. We have other participants. So in regulated electricity markets, you have vertically integrated utilities that control generation, transmission, distribution. Prices are set by regulatory authorities based on cost of service models. So you're rewarding the utility for being there. You're saying you can have a limited reward for provisioning this service. And there's a focus on universal access, reliability, and stable prices. Good examples of these are the Southeast United States and much of the Midwest. Then you have deregulated electricity markets, combined wholesale, retail electricity markets, or you could also think of them as just distributed electricity markets. Here, generation is competitive with independent power producers bidding into wholesale markets. Transmission and distribution remain regulated as natural monopolies, while the wholesale market is less regulated and has more participants, so still very regulated. Consumers may choose electricity suppliers, fostering competition and innovation, or at least that's the theory. In actuality, it doesn't really work out this way. There's a lot of questions as to how much this increases competition and decreases cost, but here, some examples, so Texas and ERCOT, PJM interconnection in California. So a key difference between the types of markets, regulated markets, monopolistic, and competitive generation. And then, regulated and then deregulated competitive generation. In regulated markets, prices are fixed by regulators. In deregulated markets, retail prices are fixed by utilities, and then wholesale prices are market-based. The innovation is in theory limited, and there's a lot of investment in projects. This is why you see mostly more nuclear and hydro, because they're very intensive in investment in regulated markets. And then deregulation, in theory, innovation is encouraged. I don't know how true that is. And deregulated markets, you have multiple suppliers for each consumer. In this case, the consumer is not the retail person. It's not you. The consumer here is the utility. Pros and cons of regulated versus deregulated markets. Regulated markets are stable in their predictable prices. They focus on reliability and universal access, and they ensure long-run infrastructure planning. The real value of these regulated markets is that they invest in the future, and they do what it takes to build out the infrastructure and build out the generation for long-term, but they sometimes do it too much. They sometimes overdo coal plants and overbuild expensive plants and get into trouble. There's limited competition, which can create inefficiencies. Maybe they're not encouraged to innovate, not really incentive for renewables, which is why they are a lot slower to implementing combined cycle natural gas and renewables, and the prices may not affect real-time conditions. And you have deregulated markets, which encourage innovation and competition. They have market-driven prices that reflect supply and demand. They have greater consumer choice and tailored solutions, and they also have price volatility that can burden consumers. They have risk of market manipulation in gaming, which is something the FERC takes a lot of look at. We talked about that a lot in commodity market derivatives. And they have reliability concerns with the decentralized generation, with the fear that there just isn't going to be enough investment because there's not one person like in the regulated market doing all of it. So deregulated versus centralized electricity markets visualize in the regulated energy market, the vertically integrated utility. You have power station, utility company, and then all of this is owned by one company, and it all gets to the consumer. And then in the deregulated energy market, power station is owned by a wholesale generator who sells it to a retail supplier. who is a utility company who transfers it to the generator. So utility companies here are buying it from the wholesale generators who supply to the retail market. So here's another demonstration of the relationships. You have generators in the decentralized market who sell in what's called an independent system operator. The independent system operator sets up the market and solves a complex optimization problem to optimally distribute electricity and then set prices. The ISO then, through this process, provides electricity to the retailers, who then provide electricity to the customers, who are us. This is how I'm recording the video. It's how you're watching the video. Is assuming you're in ISO, maybe you're not, but assuming you're in an ISO region, there was a wholesale market where a bunch of generators submitted bids. The ISO decided which ones to dispatch, and then they put them through to the utility, who put them through to the customer, us. So here's a map of the current electric grid. This is not my favorite map. My favorite map is the one I have on the wall closest to me I'm looking at right now. And it's just a beautiful one. It has all the resources from EIA as well as transmission lines. You can look it up on EIA's website. It looks great. But here's what it looks like. You really have three different grids. You have the Electricity Council Reliability Council of Texas, which is one grid. And then you have the Eastern Interconnection, which is all of this out here with all these ISOs. So all of these are different ISOs. And then you have Quebec, which is its own grid, which a lot of people don't talk about. And then you have the Western Interconnection, which is another grid. You don't just have one grid. You have several that you have. And then this is transmission expansion, which is a big project, which we'll talk about in the third section of this lecture, where you have all these very long-distance electricity projects to bring in electricity from where it's cheap to where it's expensive, and to allow more adding of renewable resources so you don't overwhelm the grid. This is a lot of what my professional career is about, is thinking about how we can have this transmission expansion happen. And yeah, DC is making a comeback. You're seeing now investments in direct current in ways that you haven't seen since the start of the 20th century. And yeah, here's the ISO map again. I'll probably mention it one or two more times. And I hope you have a great day. I'll see you next time to get started on generation. Thank you.